Welcome to Dev Prep, and today we will be discussing about divide players into teams of equal skill. You will be given an array and you have to make pairs that are having some equal to each other pairs that we will be forming, and it is given that the array will be of even size. Now we will be discussing about an optimal solution and also a brute force solution for this. Okay, so two solutions we'll be discussing in this video. So let's move ahead and let's discuss the brute force solution that comes in our mind. So I have taken this as my test case that I'll explain around. So consider that you are having 3 2 6 5 in your array skill, and what will be the possible answer in this case? If you divide them into pairs, you will say, hey, I have 3 2 6 5, what can be the pairs? So 2 and 6 will give you a sum of 8, and 3 and 5 will also give you a sum of 8. Both will be giving you a sum of 8. Okay, I can look easily via this test case and decide this. Okay, now how do I solve this approach? What like intuition for this? How should I develop it? So I can clearly see one thing. Just keep in mind before starting, even length is given and pair sum will always be equal. If it is not, you have to return 1. Okay, so let's just say you take A, B, C, D as your elements in array. Okay, now what I can say is, over here if I see, I am having the smallest summed with the largest. You see, this is a sort of thing that we can prove also. Let's say in a given array, if A is greater than B, B is greater than C, C is greater than D, right? What all possible outcome can be there, right? If I say A plus C and B plus D, this can be one possible pair, right? AC and BD, right? Now this sum A and C will it be greater than B or D? No, it won't be greater than B and D. B plus D will always be greater, because no matter what you try, you won't be able to get this feasible. This is not feasible because A is already smaller and C is also smaller than D. You cannot sum these two and get a greater value than B plus D, because B is larger than A. So that is one thing, right? And if you also do A plus B, same story. This is pretty much clear. This will also be never be possible. You even take an example. Let's say if I have 3 4 19 20, if you do 3 and 19, you will be getting something around 22, and if you do 4 and 20, you will be getting around 24, right? So there you go. You won't be able to do this, right? So this is one basic thing that we saw. This is a sort of a pattern that is happening now. Okay, so intuition behind it is, like, first thing that we can see while solving such sort of problem is sorting played a role to get to this logic. I thought, hey, let's try sorting. What can be done with sorting? Can I do something with sorting? And once I did sorting, I came up with this formula and I say, okay, these two are the valid values that are there. Cool, right? So a basic approach can be, you can sort this, you will get it in a sorted manner, and once you get it in a sorted manner, which will be n log of n, you will again traverse the array. Okay, now I got it in a sorted manner, A, B, C, D. Okay, now I will traverse the array. I will put one pointer here, one pointer here, and I will just summate it. Just do the summation of this, and then I will move my pointers, this one ahead, this one backward, start and end pointer, you can say, and then summate this. If this is equal to previous summation, we are good, and we have to repeat this process. Okay, and thus we reach to a solution. that hey, I got all the pairs after sorting, and this is their product sum. Okay, so I'll code this now, and I'll explain more while coding. Okay, let's code the naive solution first. So I will take my answer as 0, and I will sort the given vector array. Okay, no, no, normal sort. And now I will give my starting pointer as 0, and my end pointer will be this -1, since we are playing around with indexes, so it will be -1. Also I need pair sum, right? So I can start directly with the, since the constraint is telling me that length will always be greater than 2, so that's why I'm doing it over here, like just to start and then scale end. Okay, this will be my ideal pair sum as per the intuition, because you cannot add something bigger than smaller to the last value and expect that you will achieve something better, that we have already discussed. Okay, so while start is less than end, okay, if you know my scale start plus scale and does not equal to the sum, I'll simply return -1. Okay, else what I will do is, in my answer I will just summate this. Okay, then I will increase my pointer, and then I'll return my answer. Okay, let's run this. All test case passed. Let's submit it. Okay, good. Now let's code the better solution. Okay, good. Now let's come to the optimized solution. How can we optimize this? So some basic mathematical induction we will be doing to do this optimization. Okay, so let's say again, let's start with a comma b comma c comma d. Okay, and I'll say let's take with this array and just do a summation of this first. Okay, I did the summation, and I can also tell one thing, that when I'm doing this, there must be, if we are having an answer, then there must exist something like, a plus c, I can also write it in this way, right? Plus b plus d, equal to x. For my answer to exist, for a valid solution to have, I must have a plus c equal to some say y, and I also need to have b plus d for my answer to exist, right? If my answer doesn't exist, then this will be a failure in our case. But let's think that this answer is getting here, we will be getting an answer. The intuition will be developed from this perspective. When you start thinking, if I can get an answer, let's take a positive scenario, don't think about negative scenario, just think about the positive scenario for now, and then we will decide how to handle the negative scenario. Okay, so logically speaking, if I have an answer in my array, if my array is having that pairs that are having equal sum, so in that case, in perfect world, this will be true. So you will get y plus y equal to x. X is being the sum, right? Then you get 2y equal to x. Then you get y equal to x by 2, right? Side note, if you had a, b, c, d, e and f, your y value will be x by 3, right? Y plus y equal to x, right? Same step, you can add those e and f here, right? If the answer exists, it will have the solution, right? So just let's clear it out. So we are saying something here, that a pair, if a pair comes into picture, right? If a pair comes into picture, you will be getting this, a pair sum will be equal to this. To generalize this, let's say I want to generalize this concept, what I will do is, 2, if you look at closely 2 and look at 3 closely, just let's generalize step by step. What and 2 and 3, how is like this number got increased? Because I introduced one more pair, this got introduced. So what I can say is this factor, a pair equal to sum divided by n divided by 2. A pair can be found via this if everything is true. A pair can be found via this. Sum divided by total number of element divided by 2. This is one way to find the pairs. See, mathematically if I am speaking, I have 4. So what I am doing, I am dividing sum divided by 4. Here in this case I had 6, right? So here it was getting divided by sum divided by 6. If you look at this way, you also see the generalization, that is how it is happening, right? Because it's a pair after all. You are playing with two numbers around. Okay, we now know something is coming up, something in the picture is coming up by this mathematical induction. Okay, so let's get ahead and think more. What else can be done in this area? I have a formula, and what else I can do? Now if you think, you get a pair, right? You get a pair of the sum. Every number in that array b, c, d, if they are valid, right? If they are valid, combination of these two, okay, this is, or a combination of this, or combination of this and this might be equal to the pair, right? I am seeing now that if I take my number, say pair, and if I say minus a, for the solution to exist, it should give me d. Okay, if I do pair minus b, a solution should exist and give me c. So I'm seeing something as a thing as hash map over here that I can use. And let's take the same example, 3 2 6 5. Okay, let's take the same example. You have 3, you have 2, you have 6, you have 5. No sorting, nothing done till now. I'm just gonna use this formula. First I'll use this formula, total dry run for you. Okay, just simply using this formula, sum divided by n by 2. So what will be the sum? 3 plus 2 plus 6 plus 5. 6, this will be 3 plus 2 will be 8. Okay, and 3 plus 5 will also be 8. You will be getting 16 as a sum. Okay, I got 16 as a sum, and 16 divided by n by 2. N by 2 will be just 2 for me, so I get 8. So I know all my pairs, if the answer exists, pairs will be having sum of 8, an ideal way. So something around, I'm going back to the problem of two sum. If you look at it, where you were figuring out how to get the result via the summation, if this target exists, minus doing it minus. If you want, you can go and watch two sum video as well. It's available on the channel. So I'm going back to that question now, and I'm using the same approach. I get 8, I say, hey, I do this now. 8 minus 3. I say, let's, everyone is existing over here. For now, I just added as a frequency. 8 minus 3, what is going to give me? 5. Okay, so with 3, I'm having 5. Okay, good. I visited, now I will say, okay, I get a 5. I visited this. I put it as 0. I put it as 0. And now I iterate to the next value. Did I visit it? No, I didn't visit it, because by seeing this 1. Okay, so 2, 8 minus 2 will give you 6, right? Now I say, okay, 6 I have found. If I didn't found, at that specific moment I would have returned -1. I would say, hey, return -1. It's not there. Just return it, man. So we would have returned it. So this I also visited. This is also visited. So I won't be traversing this. So without sorting, I was able to get all my result. I iterated till the end, but I only calculate sum when frequency is not there. Okay, so I also am keeping a track if I have visited something or not. Now there is one more play which you need to understand. This is good, this approach is good, but edge case, I want to talk about edge case now. Let's say consider 2 comma 2 comma 2. You will be having this as an edge case, or say 2 comma 2 comma 4 comma 4. This algorithm will fail on that, right? Because you will be having some frequency, then you will have to again revisit it, right? You might not be visiting it, so you have to plan for this as well. Okay, so how do you plan for this? Basically, there is something we will say, let's say we will find a factor. We'll use factor in our code. I'll explain you while coding how I'm doing this. So I want to make this video short, so I'll explain you directly over there what I am using, why I'm using. But this approach is clear. Let's keep this in mind and let's code it. I'll have pre-coded my solution over here. Okay, so I take the size and I divide it by 2 to get number of pairs. Then what I am doing is I'm writing like I'm taking the sum, I'm submitting all from beginning to end, whatever the vector that has been given to me, skill vector. And now I'm just saying, hey, if pairs are able to, like, whatever the pair sum that I got, like number of pairs I got, is that be efficiently able to be divided. So I'm checking that. So this is for that. Then we are going to the main logic. We are trying to find a pair sum. So this will give us a pair sum divided by y. So y will be total number of pairs, and whatever the sum you got, that is divided, and then you get a pair sum. So pair sum will be something a plus c, and it will also be equal to b plus d if your answer exists. Thinking that answer will exist, and some point where it will fail, we will return -1. Okay, now we declared unordered map. We get an unordered map. Now we iterate and we map every element that we got, right? We incremented one by one, whatever the frequency is. If you say you are having an array of repeated values like 2 comma 2 comma 2 comma 2, so you also need to have a sort of frequency if you want to optimize your solution like that. Okay, and then I'm just taking a result variable, and then I'm iterating again over the map after I have done filling up the frequencies. And I say, hey, if I have already, if the frequency is 0, I don't need to visit it. Why I am going to do this? Because at one point over here I am using this pair sum -0 and making things, like if I have already visited, I'm making things 0, and since I'm doing it one by one, reason to say that is, if you look at this statement, right, I'm calculating some stuff over here. First and foremost, the best condition you should look after that is whether the other number exists, whether C exists in my hash map, whether D exists in my hash map, and this is covered by this line. If this occurs, now the question will be, hey, why are you doing second? Why are you looking for it dot second? Because I also want to match the frequencies or number of times things had occurred. Okay, so if something happened like 2 comma 2 comma 2 comma 2, okay, and something was like 4 comma 4. Okay, so there is some sort of mismatch. There is some sort of mismatch here. The sort of mismatches you are missing, you get answer with 2 comma 4 get 6, you got an answer 2 with 2 comma 4 as 6, but you don't get answer with this. So number of 2's are greater, and if a pair sum we are going with 2 and 6 first and last, the pair sum will be that only, right? Like the smallest and the largest, right? So if this is higher, it won't be like I don't have two extra fours, right? So this is a wrong solution. I need to detect it. So whatever the frequency is of the first two I have, it should be the same of the second element. Pair sum minus it dot first will give me the second element, right? It will give me the C in this. If 2 is that, then C will be that 4, right? In this case, and so 4 C should be also the same number of times whatever the number of occurrences of A, right? Just to prove this point, like equate this pair sum. So if that's not equal, then you will return -1. Now let's say if you are having an array of just this, right? Since we are making like traversal, we have already traversed, so I'll make it 0, right? So just to do that, like if you're doing this, you won't be traversing it again, right? So just to handle that, there is this piece of code that I added, and this as a factor that I added. If it's a frequency of 1, hey, let it be, just let it slide down, let it just slide down the line, whatever the frequency. If all elements are same, how do I know all elements are same? Because there will exist one array, like if you pair sum you get by multiplying it twice, if you get that, right, then the whole array is same basically. Whole array is going to be the same. There is no chance that you won't reach here. Okay, you won't reach to this state. First of all, this will stop at this test case and you won't be reaching here, right? So this will be a valid test case. And to quickly calculate it, what happens is in your hash map, if you see, right, you will have a value of 6. Since I calculated it dot first, I was trying to keep the solution generic. So if I calculated it dot first and I also again calculated it dot first, what it gave me was 2 into 2. Now I want a frequency, but I need to calculate it a bit because I already did a multiplication of 2. I doubled it down. I already did my first number, doubling it down. So my frequency will be also be halved just to keep in proportion, right? If I'm doubling down my number, then my frequency will also reduce. So that is what I'm trying to do over here. 8 dot second, it's getting reduced. That's the logic over here. That's how we are doing it. And if it's not the same, like 2 comma 2 comma 4 comma 4, so in that case just match with the frequency and you are good with it, because 2 comma 4 you multiplied and you again need 2 comma 4, just match with whatever the frequency is and you're good to go. In that case you don't need to do this. So handling that, we are doing this. There's some what is saying, oh, pay or pay some, and then here is pay some, pay some, pay some, pay some. Sorry for the spelling mistake, just want to check it, double check it. Yeah, let's run it. Okay, cool, submit it. Yeah, cool. Thanks for watching, guys.